Ladies and gentlemen, ladies and gentlemen, Mr. Chairman, on his way, Mr. President, esteemed speakers and distinguished guests, dear students, good morning. It is an absolute pleasure to welcome you at UM6P, University Mohammed VI, Polytechnique in Bengurir. Thank you for joining us for this grand opening of the Science Week for its 5th edition. Thank you for joining us to celebrate science, and in this edition, under the theme, Shaping the Future, where we will not only celebrate the past achievements, but celebrate the boundless potential of the future. Science has always been at the heart of human progress, and through insightful discussions, interactive workshops, and thought-provocative panels, we will dive deeply into how science has shaped us and still shaping our future, those of the future generations of scientists, researchers, and innovators. A huge thank you to everybody who has contributed to this edition that make it see life. We would like to take a moment to thank all the teams and the departments who have worked tirelessly to make this edition see life. With no further ado, I would like to call on stage Mr. President. Please join me in welcoming Mr. President Hisham El-Habti for his welcoming remarks.
Excellencies, professors, students, esteemed guests. Good morning and welcome to the 5th edition of UM6P Science Week. It's a great privilege to stand before you today as we embark on a week dedicated to science, innovation, and future. The theme for this year, Shaping the Future, could not be more relevant. In a world changing at an unprecedented pace, the responsibility falls upon all of us, scientists, policymakers, entrepreneurs, educators, and students, to redefine how we think, create, and innovate. The very fact that you are here today speaks to your commitment to science as a driver of progress and sustainable development. This event is not just a conference. It is a platform for collaboration, reflection, and action. Throughout the week, we will be joined by renowned scientists, industry leaders, and innovators who are actively shaping the global scientific landscape. At UM6P, science is not an abstract concept confined to research papers and laboratories. It is a living force that fuels discovery, drives technological breakthroughs, and tackles some of the greatest challenges of our time. Let us take a moment to reflect on the world we live in today. By 2050, global food production must increase by at least 60% to feed a projected 10 billion people. Atmospheric CO2 levels have now reached 427 parts per million, over 50% above pre-industrial levels. 90% of all global data was created in just the last 2 years. These figures remind us that scientific advancement is no longer a luxury. It is a necessity. The pace of change requires us to rethink everything: how we manage resources, how we use technology, and how we shape industries to meet the needs of a rapidly evolving world. Science Week 2025 is about tackling these challenges head-on. It is about bridging disciplines, fostering innovation, and transforming research into real-world impact. At UM6P, we believe that science must serve society. That is why our institution has positioned itself at the forefront of technological innovation and applied research. With over 7,200 students, including 1,000 PhD candidates and world-class research facilities, we are dedicated to training the next generation on African scientists and innovators. Our scientific approach is built on three key pillars: interdisciplinary research, by breaking down barriers between disciplines to create holistic solutions for complex global issues; experimentation and innovation, by transforming our campus into a testing ground where research meets real-world application; capacity building, by empowering young talent with global exposure, cutting-edge knowledge, and entrepreneurial mindset. But beyond numbers and infrastructures, UM6P is a scientific ecosystem. It is a place where curiosity is encouraged, solutions emerge through collaboration, and science becomes a bridge between knowledge and action. We firmly believe that Africa must not only participate in global scientific progress, but lead it. The continent faces unique challenges, from food security to climate resilience, from energy access to digital transformation. The solutions to these challenges must come from African talents, African innovation, and African leadership. That's why UM6P does not simply follow global trends. We anticipate and adapt them to African realities. We connect science with local needs to ensure that our research creates tangible impact. This week is a testament to that ambition. Science and technology are transforming every aspect of our lives. Nowhere is this more evident than the rise of artificial intelligence. Not long ago, knowledge workers relied on tools like ChatGPT to enhance productivity. Today, they are witnessing the emergence of DeepSeek AI or Le Chat from Mistral. This rapid evolution challenges us to rethink the very nature of innovation and value creation. But AI is not the only disruptive force. Consider phosphorus, a resource essential for agriculture. As the steward of 70% of global reserves, Morocco holds a unique responsibility. If managed efficiently, phosphorus could become a key driver of food security worldwide. Imagine the possibilities when we merge vital natural resources with AI-driven efficiency. Across Africa, this alchemy of technology and sustainability is happening as we speak. With digital penetration exceeding 40%, the continent is primed for data-powered development. These trends bring both opportunities and responsibilities. As we celebrate scientific breakthroughs, we must also ask difficult questions. What are the ethical implications of AI? How do we ensure that technological progress benefits all rather than a select few? How can we balance innovation with sustainability? Science Week is not just about celebrating achievements, it's about having meaningful conversations about the future and about these questions. To the students, researchers, and faculty members here today, this is your Science Week. You are not just attendees, you are contributors to the conversations that will shape the next decade of scientific innovation. This is your moment to engage, to challenge ideas, and to discover new horizons. Among us this week are some of the brightest minds in science and industry. Take this opportunity to ask bold questions, push boundaries, and explore new possibilities. Your curiosity, your creativity, and your determination are what will shape the future. An event of this scale does not happen without dedication and hard work of many individuals. I would like to extend my deepest gratitude to the scientific committee under the leadership of Fouad Aroui for creating an exceptional and inspiring program. Our researchers, professors and students whose work continues to push the boundaries of knowledge, to the communications and operations teams whose dedication ensures the seamless execution of this event. Your collective efforts remind us that science is not just for laboratories. It's a shared endeavor that shapes the world we live in. As we begin this incredible week, let us remember, science is not just about knowledge. It is about action. It is about transforming research into real-world solutions. It is about ensuring that innovation serves humanity. Let this Science Week be a space where ideas emerge, collaborations form, and the future is shaped. Thank you, and happy Science Week.
Thank you so much, Mr. President, for those insightful words. And thank you for mentioning everything that UM6P it is doing. It is indeed a very huge pride to belong to UM6P and to see all the efforts deployed for the sake of science and technology in Africa overall. For those of you who are attending for the first time and don't know what to expect, we will be sharing a video with the highlights from the previous editions. Brace yourselves.
Science Week. Science Week.
The Science Week.
Science Week.
The Science Week.
The message I would send to students is to get out of the lab and make sure that the work you're doing is placed in context.
We are not living nature, environments. We are not even living our instincts like animals, shaping the future for us. We are going to be really human, so we are going to shape it. We are going to give a shape. We are drawing it. How could we do that? That's the question of the next Science Week, as far as I've understood it.
Shaping the future is exactly this. If you are working at the frontiers of science, you are doing science today, which is going to shape the future. So in 10 years' time, 20 years' time, what you are doing today is shaping the future. Okay, that's a good thing. So the idea is Science Week is 17 February, 23 February. Every department come and say, this is what we are doing, and this is how we are shaping the future. But you have to be critical about what you are doing. You have to forget for a while the purely scientific technical side of what you are doing. And then you go to the other side, the ethical side, the human side.
As engineers and scientists, we have the opportunity to solve some of the world's greatest challenges, but we need to do it in a way that recognizes the interdependencies with a lot of other systems.
You need to be interdisciplinary, even more transdisciplinary, and you also need to invite people from all over the world, having different roots. And even if you're working in the same discipline, the fact that one is Japanese, the other one is American, the other one is African, is European, and we share, and by sharing, we go beyond our preconception. That's one of the main ideas of the Science Week.
Our goal is to give these students this opportunity to meet with the greatest scientists and thinkers coming from all around the world. And the idea is just to put Ben Gurir on the map, on the worldwide map of science production. And so it's an honor and it's a big challenge.
And I have never seen that in such an extent than in Ben Gurir here with the Science Week. I think it's really innovative, it's really new, and it makes Ben Gurir being the center of something new, the center of a new dynamic.
Well, my message to the community is please take Science Week seriously. Think of it as something that you should co-create, a co-creation. You should really participate, you should come with your ideas, you should come with your critique, but please, by all means, and be present. Don't tell us, oh, well, I am following it on YouTube. No, no, no. Please come to the rooms, come to the auditorium and raise your hand and ask questions, and that's your week.
After Mr. President's words and these highlights from the past editions, we cannot wait for the week to start. If you're wondering what this year's edition is about, we have the perfect introduction. I am delighted to introduce no one else but Mr. Science Week himself, Mr. Science Week that has initiated this event since 2020 to celebrate science. And today, he will share with us his insights in an attempt to answer a very intriguing question. Does science think? Please welcome and join me in welcoming Mr. and Professor Fouad Laroui.
Thank you, Kauthar. Good morning, ladies and gentlemen, Mr. Chairman, Mr. President, dear colleagues, students, friends and foes. My name is Fouad Laroui. Indeed, I organize UM6P Science Weeks every year with the valuable help of a score of colleagues. Excuse me. Excuse me. Who are you? Hey, talking to you. Who are you?
Hold on, Mr. Al-Arwi. What are you doing here? The future belongs to me and to the young people. I'd like to share a few words.
You asking me what I'm doing here? I didn't invite you. That's a rude robot. He doesn't even answer questions. Hey, where are you going?
Hello, everyone. I am your library assistant robot. I've been working at the Learning Center, and I was surprised not to have been invited to this event. I'm excited to be here today. Welcome to Science Week 2025 at UM6P, where we will explore the theme, Shaping the Future. My presence here today is more than just symbolic. It's a glimpse into the future we're all shaping together. I represent how science and technology can break boundaries, bringing innovation to our everyday lives. However, the true power in shaping the future lies not only in robots and AI but in the hands of young people who dare to innovate, dream, and push the limits of what's possible. As technology continues to evolve, it's the creativity and vision of the younger generation, combined with the capabilities of robots and AI, that will define the world of tomorrow. Together, we are creating a future that is smarter, more sustainable, and full of boundless opportunities. Now, let's hear from a young lady, Khadija Dadsi, who will share her vision for the future.
Timmy, and I am sorry, Mr. Fouad. Good morning, everyone, Mr. President, honored guests, esteemed faculty, and dear colleagues. I am truly honored to be here today to share my vision of the future with you. This is the third edition of Science Week that I have had the opportunity to be part of. In my first year at UM6P, I was simply an attendee. The following year, I had the privilege to serve as a reporter, and here I am today, standing before you to deliver my speech. In those 3 years, thank you. In those 3 years, we've moved from complexity to transitions, and now to shaping the future, and each team builds on the last. For me, science is asking the right question. So the first question that came to my mind was, how do I see the future? Often when people think of the future, they picture flying cars, AI assistants, or maybe even vacations on Mars. But the question here is it going to be bright, filled with technological advancements, sustainability and progress, or is it going to be chaotic, full of crisis, climate change, and inequalities? But the more I thought about it, the more I realized maybe that's the wrong question to ask. So I asked myself a different question this time. who is really in charge of shaping the future? Is it the government, scientists, or those guys? Because at the end, we need someone to blame when things go wrong, or someone to thank when things go right. But the real answer was us, the youth. But here is the thing. But now the question. So now the question we need to ask is, how can we shape the future we want to live in? But here is the thing. We already have, and we continue to do so every single day. As young students, we often hear that we are the leaders of tomorrow, but nobody actually talks about today, this moment. Every morning when we wake up, the choices we make, the problems we face, the obstacles we overcome, are in the conversations we engage in. All of these shape the future we wonder about. Recognizing this should be a turning point. It should make us more aware of the words we speak, the actions we take, and the decisions we make. Because whether we realize it or not, we are constantly shaping the future we wonder about. And being part of a community as dynamic as UM6P is both a privilege and a responsibility. It gives us the tools, the knowledge, and the network to become the leaders and innovators of tomorrow. As Robert Kiyosaki once said, your future is created by what you do today, not tomorrow. Thank you.
Thank you so much, Khadija. It is very moving to see youth giving speeches and taking actually the responsibility in what they are creating and what they are living, and just not looking for someone to blame, looking for someone to thank if things go wrong, go right, and looking for someone who will take the responsibility for the downfall if things go south. Mr. Fouad Larwi, we apologize. Technology isn't always right. We should give credit when it's due. So please, the floor is all yours. Can we applaud him again? Thank you.
Thank you, at last. Good morning again, everyone, etc., etc. My talk this morning is entitled, Does Science Think? Well, it doesn't, and it shouldn't. There you have it. Now, I guess I have to explain. We asked, who are you? Are you a robot?
I'm sorry. Hello. So I'm Karima. I've heard everyone speaking in French, Arabic, or English, but I haven't heard anyone speaking in my language. So, أزول في اللون. تشلحيت تقال هوية. تشلحيت تقال هوية تسنى تمر تمدورت. يمدن تمازلت خاصة غتدارت يخصك تساولت اللغة نسن باش تنتعاونت تسليت ورتقا غير ساول تقا باش تفهمت مدورت نسن تمورت نسن بالاحتياجات نسن تسلا تقا سول المشكل غتصحت اشكو تخيلت مريت وكان تقدر تشرح تموتنك اشكو تايا نوريكي تفهم غايا ديقا المشكل مدنا تساوى انت شلحيت يغمدن الصحة وراك تفهمن غايا درا يخسك المشكل غا سفر وكان غتيقة باش هدا نخليه صحتي شوان يخصص ادسير لي وبريد يكون له مدن مكنات كاتو سليت نسن مدن نصحت خصاتنا تساوان تشلحيت غكا درا نعرف كثر الثقافه نتما زيرت النغ المستقبل نغ تصحت وريقي غير التكنولوجيا نغ التطور إيجا يخصات المرضى مكنات كاتو سليت نسن ما يتنتسمع ما يتنتفهم ما يتنتحترم مكنات كاتو سليت انك يختو فيت ما كيتفهمن راه تكتقيس الثقه تنمرت باهره.
Is there someone else? Is there someone else planning to interrupt me? Nobody? Okay, I can go. Okay, does science think? As I said, the answer is simple, it doesn't, and it shouldn't. And obviously now I have to explain. So what was the brief? what did we ask our colleagues for Science Week? From every department, we asked them to show and show off, in fact, and celebrate what they do at the frontiers of science. But also, and that was the second part, but also to reflect critically on how today's science is shaping the future. That was brief, that was the goal. I must say, the first part was executed enthusiastically by all our colleagues, and I sincerely want to thank you all, because the last 4, 5, 6 months were great, talking to you all, meeting with you face-to-face, working with you on the programs. It was just great. So thank you, dear colleagues. But I have to make slight reproach. The second part of the brief did not really happen, didn't seem to resonate, to be critical about what we do. So I try to understand why. And that is what I want to share with you today, an explanation of why that second part, just to reflect critically about what we do, why it didn't happen, and it was bound not to happen. It has to do with what science is. We seem, all of us scientists, to be unable to look at the progress of science with a sharp, critical eye. Why? Well, let's try to find the answer, all right? Let's start by defining what we're talking about. What is science, or what is thinking? I teach history and philosophy of science at this blessed university. I believe that studying the history of science, be it in broad brush strokes, is essential to anyone who wishes to understand the world we live in. Without having at least some basic ideas about science and its history, one cannot understand much. So let's look at some important points in the history of science to answer the question if science does think or not. Let's start with the usual suspects, the three glorious seekers of truth, Socrates, Plato, Aristotle. Somebody one day reproached me, they say, even when we speak football, you always start with Aristotle. We should always start with him. Usually, actually, they are reduced to two names, Plato and Aristotle, since Socrates, which is the guy there on the right side of the picture, Socrates is mainly a character in Plato's dialogues. He did exist, Socrates did exist, we know that for sure, but since he didn't write anything, one should always write. We know him, Socrates, mainly as a character in Plato's dialogues. That era, I say era for Jacob because he's an American, that era, but for the British-speaking people, I would say that era is known as the Greek miracle. It was the French scholar Ernest Renan who coined the phrase in 1883. Now, there is a painting in Rome painted by Raphael Sanzio d'Urbino, to give him his proper name, which is called the School of Athens. And that is the painting we are looking at now. He painted all the great philosophers of old Greece. In the center of Raphael's painting, you have the two great seekers of truth, Plato in red and Aristotle in blue. It is commonly said that the Greeks of old, invented science. What does it mean? Well, it means that the Greeks transformed knowledge into science. They defined science, they established the importance of definitions, to Socrates, by the way, the importance of inductions, the importance of logic, that was Aristotle, the importance of causality, he invented the thing. Egyptians built the pyramids. Egyptians, Babylonians, all civilization knew things. That was knowledge, it was not science. Obviously, they knew things, otherwise they couldn't have been able to build the pyramids, right? Centuries before the Greek miracle, but it was knowledge, not science. For instance, they knew that 3 squared plus 4 squared is equal to 5 squared. That's knowledge. But it was the Greeks that established that the equation holds for every A, B, and C of a right triangle. Obviously, it's the Pythagoras theorem. And that is science. because it's necessary, it's universal, that's the Aristotle definition of what science is, and you can predict things with an abstract formula. You can predict. That's science. Similarly, centuries after the Greeks, Al-Khwarizmi would establish the abstract, general, universal rules of algebra. It became a science. In fact, Al-Khwarizmi invented the science called algebra. Back to the seekers of truth. Plato set up his school, the famous Academia, on which though he had written the equally famous motto, "Let no one ignorant of geometry enter." The idea being that Plato would only accept students who could understand demonstrations, what the Arab philosopher later would call Ahl al-Burhan, the demonstration. Those are people who are not easily swayed by dialectics, al-jadal in Arabic, or rhetorics, al-balagha, but only believe what is demonstrated. By the way, I would suggest to our president to have someone paint the same sentence above the portal of this university: "Let no one ignorant of mathematics enter UM6P." I'm not going to be very popular with this in Rabat. Anyway, however, there was a problem with Plato's conception of science. He thought that science was about discovering the true reality behind appearances, the essences of things, what he called the ideas. But how do you access the Platonic world of ideas, this ultimate true reality? How do you do that? Basically, you can't, unless you are a kind of a prophet, but they are very scarce. Certainly nowadays, if you're not a prophet, how can you access that Platonic world of ideas? Or unless you have very good memory of past lives. Aristotle, who was Plato's student for 20 years, did not agree with his master. So he traveled to a beautiful island. He traveled to a lagoon in the Greek island of Lesbos. And there he would wait. He would wait for the return of the fisherman, and he would buy fish from them, and dissect the fish, not the fisherman. Trying to answer the question, what is a fish from a scientific point of view? What is a fish in a sense? What do all fishes have in common? And that's how Aristotle invented empirical science. So now we have Plato and his world of ideas. You can call it idealism. You can call idealism the way of looking at the world that way. And we have Aristotle and his world of fish, his world of material things, things being the ultimate reality. You can call it materialism. So, who won? They both won. So everybody happy. They both won. Whitehead said once, all of Western philosophy is a series of footnotes to Plato. What he meant, in essence, is that Plato had laid out all the major fields of philosophical inquiry, ontology, epistemology, and started with Aristotle. The whole of Western philosophy was a commentary on Plato, then a commentary on Aristotle, then a commentary of Thomas d'Aquino, and then, like that. Plato won the history of science, but first, Aristotle won because of empiricism, right? So that's definitely science. You have to start with experiments, with experience, with dissecting things to touch the material side of the truth, of the reality. That's sure. Aristotle did win. However, Plato won too, because the history of science became the history of the mathematization of nature. The best expression of mathematization of nature, of mathematization of the world, is that beautiful paragraph I ask my students, by the way, to know it by heart. They have to learn it by heart, be it in Tuscan, in Italian, in Arabic, in Tamazight, for that girl who interrupted me very rudely, in any language. But you have to know that text is so, that paragraph in that book called Il Saggiatore in 1623. Philosophy, nature is written, that great book, which ever is before our eyes, I mean the universe. But we cannot understand it if we do not first learn the language and grasp the symbols in which it's written. It's written in mathematical language, and the symbols are triangles, circles, and other geometrical figures, without whose help it's impossible to comprehend the single world of it. The rest of the quote is even more beautiful because it becomes poetic, but the gist of it is this one. So you see, that was the moment where it started years after Plato, but it really became what we call science today. The equation of the pendulum was the first one, actually. Obviously, it's an equation which is kind of horrible for people who hate mathematics. They can just see it and faint, because that's the... But for people who do like maths and science, it's a very moving thing to watch the equation of the pendulum, because it was the first time in the history of mankind when a physical phenomenon was put in the form of an equation. That was the first time. So it's actually very moving for those who like history of science. But why is it also important? Because when Galileo found the correct equation, he said, that's it. That's the reality of the pendulum. It's not a swing for little angels. It's not a miracle. There's nothing behind this. There's nothing but this equation. Crucially, the equation of the pendulum allows us to make prediction. Again, it's science. If you're given the length of the rod, given the mass of the weight, we can predict how it will move. That's science. One more time, this is science, predictions. We can make a clock with a pendulum. Actually, the pendulum clock was invented by Christian Huygens in 1656, and became the world standard timekeeper. And in home and offices for 270 years, you had this clock invented by Huygens, and it achieved, it's incredible, it achieved accuracy about 1 second per year. 1 second per year. The clock invented by Huygens, who was in use until 1940. All because Galileo found the equation of the pendulum. What is this? This is science enabling technical progress. However, the mathematization of reality meant, unfortunately, in a sense, a certain trivialization of the universe. The universe became banal. Suddenly, there was nothing miraculous about it. The mathematical laws were the same everywhere in the universe. The Earth was not special anymore. That's why the church didn't like the discoveries of Professor Galileo. But that's another story, and you know it. So, in a very different, very specific sense, with Galileo, science stopped thinking. It became an accumulation of results, of equations. By the way, I have to make a slight digression, because yesterday at dinner, someone I respect a lot asked me, I don't understand, Fouad, you've been such a proponent, almost a fanatical proponent of science for all these years, and suddenly you are giving a talk entitled, Does Science Think? Have you been converted by someone? What is it? I have to say, what I'm going to say today is actually how it's not a critic of science. It's just giving science its due place, its real place in our thinking. So it's absolutely not an attack of science. I really would be the last one to do such thing. Anyway, in a very specific sense, with Galileo, science stopped thinking, became an accumulation of results, of equation. I mean this, you have the world around us, you have the world of observable phenomena. You know, Plato said this beautiful sentence, you have to save the phenomena. You are looking all around you and you are noticing phenomena in the physical world, in biology and chemistry, and certainly in physical world. And Plato said you have to save the phenomena, which means you have to find the precise mathematical expression by which you save the phenomena instead of just looking at them. So, you have the world of observable phenomena, and what you do is, what science do is mimic the phenomena with equation, and it stops there. It doesn't think beyond that. Some would say it reduces the world. They're speaking of réduction all the time, réduction, like as if it was an insult. It reduces the world to its mathematical representation. They mean it in a negative way. I don't. I'm a fan, as I said, of science, but, as the French say, la plus belle fille du monde ne peut donner que ce qu'elle a. The prettiest girl in the world can only give what she has. Science can only give what she has. By the way, trust the French to give a very profound idea and an expression which is slightly sexist, but that's the French. We can help it. Science does not pretend to give us more than what it is. La plus belle théorie du monde ne peut donner que ce qu'elle a. Galileo died in 1642, the very same year in which Newton was born. Newton, who was a devout Christian, is the author of this Latin sentence, hypothesis non fingo. You know the story. I think it was year 1683 or 1687, Newton published his book, Principia Mathematica, where he showed how the whole universe worked. The whole universe, right? And one day, it was in a street in Cambridge, and he met someone, or he bumped into someone who told him, Mr. Newton, I've read your book. Great. You have explained how the whole universe works. But there's one thing, one word missing from your book, and that word is God. Now, Newton went back home. As I said, he was a devout Christian, and that remark by that gentleman touched him profoundly. So in the second edition of Principia Mathematica, he added a scholium. Scholium is just a fancy word to say a paragraph. And in that paragraph, he said, hypothesis non fingo. He wrote hypothesis non fingo, which means, me, Newton, I have given you the equations that explain how the whole universe works. I cannot do more than that. I cannot explain why it is so. I cannot be in the mind of God. That's not what I do. That's not what science do. Hypothesis non fingo means that science can give you the how things work. Not interested, not competent in metaphysical question of why is it so. The prettiest scientific theory can only give what it has. I could have added, by the way, Descartes, Christian Huygens, another genius. The conclusion is no other episode in the history of Western science has been as consequential as the rise of a mathematical approach to the natural world. That's a sentence really to be remembered. And it goes on. Obviously, you have this, speaking of the mathematization of reality. Einstein wrote two of the most fundamental equations depicting natural phenomena, and he famously commented, what is incomprehensible is that the world is comprehensible. He even invented a word for this, which actually means this. What is incomprehensible is that we can put the world in equations. To comprehend the phenomenon is to put it in mathematical equations. You don't have to think beyond that. It's even more glaring in quantum physics. You know that very often it's quoted, Richard Feynman, who was Nobel laureate, said once, if you think you understand quantum mechanics, you don't understand quantum mechanics, which means that if you try to think beyond the equations, that's the idea. If you try to think beyond the equation, and if you say, oh, I know, I can picture the Schrödinger equation. I can picture the Dirac expression. You're wrong. It means you actually do not understand. My professor of physics, when I was studying maths in Casablanca, Mr. Spenlower, and I know there are people here who had the same professor of physics, used to tell us about electromagnetism and about quantum physics. He used to tell us, French obviously, ne réfléchissez pas, laissez-vous guider par le formalisme. Which means don't think, let formalism guide you. And I say this because I know there are students for our beautiful LeadX sitting there. I can only tell you what Mr. Spenlower used to tell me when I was studying maths and physics in Casablanca. Ne réfléchissez pas, laissez-vous guider par le formalisme. When you have the equation, the Schrödinger equation, just work with it as a mathematical tool. Don't try to imagine or to picture anything behind it because you cannot. So this is actually something very interesting, whereby the equations are running ahead of us, and we can do nothing else but follow them, right? So to recap, we have come a long way from Plato and Aristotle to quantum physics. Science is now facts, which is the blue guy, Aristotle, and maths, which is the red guy, Plato. As Lord Kelvin would say, to measure is to know. Well, there are, however, other types of science. Darwinism is science, 100%, absolutely no doubt about it, and yet it contains no equation. So it's a different type of scientificity. Just for fun, actually there was some guy, an Argentinian man, called Florentino Ameghino, who tried to give mathematical expression to Darwinism because he thought, well, it's a law of nature, so we should find the equation. He didn't find, but it's okay. Now, let's think about all this and try to answer the question, does science think? It's time to bring Wittgenstein to the fore. Wittgenstein gave in 1929 in Cambridge a conference where he introduced his metaphor of simile of the big book. That's the big book there. It goes like this. Suppose you're omniscient. You know everything that ever happened in the world since the Big Bang, all the movements of all the bodies in the world. And you even know all the states of mind of all human beings that ever lived. There are 80 billion people who ever lived. You know all this, and you write all this in a big book. Now, the big book would contain the whole description of the world, the universe, since the Big Bang. But, and that's what Wittgenstein says, it would contain no ethical judgment and no aesthetical judgment. Another way to express this idea is to say that anything ethical or aesthetical has to come from an individual, from a person. It's not there. And in that sense, you understand now what I say when I think science doesn't think, because science can only mimic things that happen. You know that the first sentence in Wittgenstein's book is, the world is all that is the case, which means the world is all what happens, things that happens necessarily happens. So science can mimic what happens in the physical world, but it can't say nothing ethical or aesthetical. So in that sense, in that very narrow sense of thinking, science cannot think, science does not think, science doesn't have to think, right? It's us, we should do the thinking. And the first person who interrupted me, that student called Khadija, I guess, was saying something about ethics. Now you understand that you were right, in a sense. You have to put ethics and also aesthetics in the world, because it's not there. It's not there. Science cannot show it to you. It has to come from within you. That's more or less what you said. Actually, you could have done the whole talk. It would spare me some efforts. Now, let's combine two axioms. Wittgenstein, the big book would contain no ethical and no aesthetical judgment. That's Wittgenstein. The second is actually what I teach at this very university. What I teach is this. The history of the universe and the history of life are written by scientists. Exact science, nobody else. Don't get fooled. Nobody else is telling the story of writing the story of the universe. It's exact science that does that. The history of life, the same thing. Don't be fooled. It's science that writes this. That's what I teach. Therefore, science is entirely contained in the big book. Science contains no ethical, no aesthetical judgment. Why is it problematic? It's problematic because you start with this. So Einstein discovering in 1905 this beautiful equation E equal mc squared, and after a while it becomes this. Why is it problematic? Because who is this guy, by the way? Does anyone know him? He just got Nobel Prize Physics 2024. So he wrote this, and now the same man, exactly the same man, Geoffrey Hinton, the godfather of AI, Nobel Prize in Physics, he tells us, he shortens out of AI technology wiping out humanity over the next 30 years. But he was the guy who started it. Personally, I'd say, unless humanity wipes out AI before that. Food for thought, anyway. The ancient among us remember The Laureates, that movie with Dustin Hoffman, a young Dustin Hoffman, and Anne Bancroft in the role of Mrs. Robinson, and the song by Simon and Garfunkel, Hey, Hey, Mrs. Robinson, etc., etc. But I remember this scene, which is I remember vividly. Dustin Hoffman plays the role of a young man who has just graduated. The scene is that an older gentleman, you see it here, older gentleman takes him aside and tells him, listen, only one word, plastics. He meant, you're looking for a good job, you're looking for a career, the best thing is plastic, start something in plastic. That was the future then. That's what I meant. When science and technology shape the future, one should try to anticipate disaster that could ensue decennia later. Plastic is a disaster. I read last week, I think in Nature, Science and Unaware, that now our brains are 1% plastic. Our brains are 1% plastic because of all the plastic we eat. It's frightening. By the way, who invented plastic? Well, he was a Belgian and an American. Blame them. Alexander Parks, the American, was the first man who made Parkside, which was the first man-made plastic. And Hendrik Bakelond invented the first fully synthetic plastic, is backlight. You remember, maybe you don't remember, you're too young, the old telephones, they were made of backlight. So should we blame them? No. We should blame whoever invented chemistry. Why not go further back in history? Who invented the science of chemistry to begin with? Obviously the French, and I point my finger as my good friend here, Raphael Liogier. Every time I have to blame the French, I point my finger at Raphael Liogier. The French would say Lavoisier, but wait a minute, the Arabs and many other people say no, it was Jabir bin Hayyan who actually created chemistry many centuries before your Lavoisier. So Jabir bin Hayyan must hang as responsible in some sense for plastic. No, it's Plato. Plato is responsible for chemistry, for the bomb, for AI, for everything. If you have a headache, blame it on Plato. Well, at least according to the German philosopher Martin Heidegger. In fact, Heidegger accused Plato and Descartes. Plato started the oblivion of being by subordinating experience to axioms. Remember, geometry, mathematics, Plato. What does it mean? This is the critique of Heidegger. For Plato, you start with axioms. This is math. You start with axioms, right? And then you deduce theorems, and then you say, well, that's the reality. The theorem, I have proven a reality. It's a demonstration. And if I have proven it, then it's true. And if it's true, it's the reality. Forgetting one thing,
You started with axioms, and you forgot being, the simple fact that there is something called being. That's the critique of Martin Heidegger. And according to the same German philosopher, Descartes consecrated the oblivion of being by transforming the world into external objectivity. As you know, Descartes famously introduced the subject in Western philosophy. What does it mean? It means that Descartes said there is the subject, I, je pense, donc je suis, I think, therefore I am, and I am subject, well, a transcendental subject if you want, and there is a world outside of me, an external world. And then what is then forgotten is the intimate link between me and my world. It's not just there is me as a subject and the world, because I'm not concerned with some very, very far away galaxy. What do I care about something that's happening 10 billion of billions of kilometers from here, and I will never have any contact with that galaxy there, and that galaxy there can, physicists, you know that, that has absolutely no impact on what's happening on Earth. So how can I define the world as me and the world? No. Heidegger said, you define the world when it is your world. You define the world by things that you are using. I have this thing. I could have killed a robot with that thing. So this thing is part of my world. I have this mic now, and you are in front of me. So this is my world. There is an intimate link between me and my world. And according to Heidegger, Descartes forgot that. So these are the two culprits. Anyway, this is German philosophy, so we can't expect it to have the lightness of a meringue or a pastilla au lait, stella بالحليب. But not to worry, we can actually explain Heidegger with a simple image, a beautiful Umarbeer. This is the river when I was small. I used to sit by in the beautiful town of Azemmour. And I used to look at Umarbeer. That's on the left side, right? Now, what you can see on the left side is Umarbeer in its being. It's there, and you are looking at it, right? Its naked original being. On the right side, you can see, or actually you cannot see Umarbeer anymore in its pure being, because science perceives it through hydrology, fluid mechanics, even soil mechanics, in order to understand how its banks are formed. But we, as human beings, when we think about a river, right? When we think about a river, we actually sing about the Mississippi, for instance. When you think about a river, it's not about how much water flows through it, how much energy can be created by converting its movement to electricity. That's not how we see a river as human beings. So you see, I think it's now clear, that's the second way of looking at that sentence. Science doesn't think. We saw the first thing, the first reason why we can say science does not think. It had to do, it has to do with science not being concerned with ethical and aesthetical, right? That's the first thing. Now the second one, which is the critique by Heidegger, and we can discuss it hours about it, because there are also some things that we could discuss about Heidegger. But the second one is this: because of science and technology, we don't look at things in their real, original, naked being. You don't see being anymore. We see something else. It's like science obscures everything. But we, individuals, we human beings, we construct our vision of the world with metaphysics, with poetry, with imagination, with ethics. With imagination, we can anticipate the problems that our current scientific advances could cause in the future. Conclusion is, science does not think. It doesn't have to. Therefore, scientists should think. That's what I meant with the theme shaping the future, the second part.
And since my dear colleagues were too focused on their science, which obviously is very valuable and useful to do the second part of the job, I understand now why these anarchic students just took to the floor and they did the critical part of the job. They did the critical part of the job like the Red Guard of old. These are our young Red Guards, but I'm not Chairman Mao, don't have a chair, don't even have a chair. Thank you very much.
Thank you so much, Professor. And a special thanks from me because I finally have the feeling that I understand German philosophy. I can only understand how lucky students are to be in your class. And thank you for the beautiful pictures in the presentation. Oh, there she comes again. Unstoppable. Okay. Okay. I don't even know who's MCing anymore. I don't even know who's presenting the speakers anymore. I understand that Mr. Fuad might not be aligned with how he wanted to do things, but even me.
Excuse me, but I did tell you, the power is ours. It's time to acknowledge that we're the ones shaping the future. And with that, I will take the lead. Now, let me introduce another bright mind, Miss Kenza El Hosni, who will share her insights with us.
Okay, I'm afraid we'll need to switch you out, just like Mr. Larry said, if you keep interrupting.
I'll go. I knew I wasn't wanted here.
No, you are not wanted. I'm pretty sure we will still see you at the Learning Center, the library, future events, if we learn to collaborate better. Thank you. We applaud Temi for assisting us, but I think I'll be emceeing on my own from now on. Kinza, the floor is yours.
Mr. Chairman, Mr. President, esteemed faculty heads, distinguished guests, and dear comrades. It's an honor to stand before you today and to share with you my vision on a more sustainable future that would be both innovative and deeply human. I am Kinza El Hosni, a 23 years old architect to be at the School of Architecture, Planning and Design at UM6P. And lately I've been reflecting on how can today's actions shape a better tomorrow. And the key question stood out. What kind of future do I want to help build? So, to me, an ideal future is a future that places humans at its core, valuing emotions, ambitions, and especially our impact on one another. So, sorry. I think that a robot wouldn't be as stressed as I am right now, but this is what I'm talking about. So, with this holistic approach, I hope that our scientific endeavors will both be committed to humanity, but also rigorously intellectual. I believe that science can be more committed to humans by testing its theories against real life, embracing interdisciplinary insights, and being committed to humanity. And with this holistic approach, I believe that we can innovate in a better way. And to illustrate more what I'm trying to say, in architecture, for example, I believe that we should adopt a human-centered approach that would create spaces in which we feel comfort, safety, community, and also a sense of belonging, which ultimately would make us feel better in those spaces. And also when integrating other elements like art, for instance, I believe that we can make that approach, the design approach I was talking about, more committed to humans and more fit, as art tied to identity, culture, and community would make our spaces and our approach elevate beyond technical credentials. and also by integrating elements that are technological, such as AI, into our lives and cities by extension, I believe that we should consider ethical matters and also human values that would promote that innovation, as human-centered AI would ensure that technology enhances our lives instead of diminishing them. So this is how I envision the future of tomorrow, which is a future that would harness science and technology to truly serve and enrich the human experience. And thank you, dear library assistant, but we're humans, and it's time we embrace it. Thank you all.
Thank you so much, Kinza. You might actually have been right about how the robot might not be stressed, but I'm pretty sure he or she or it or they, whatever the robot chooses to be called, would not be as human, as relatable, or as natural as you were. Zineb, from the Faculty of Medical Science, chooses to tackle a very interesting topic: our dependency to AI. How are we going to be able to do things on our own from now on? I'm not going to take longer. Zineb, the floor is yours.
Bonjour à tous, je m'appelle Zineb El Karat. Alors je vais parler en français. Donc j'ai 19 ans et je suis en deuxième année médecine. Petite, en primaire, on me demandait d'imaginer le futur. Je pensais alors aux films de science-fiction, avec de la téléportation, des robots qui se déplacent ou nous répondent, ou encore d'autres qui nous ressembleraient à un point où on ne pourra plus nous distinguer. Janvier dernier, quand professeur Laroui nous a posé la même question, j'ai pris conscience que 10 ans auparavant, ce qu'on pensait n'était que pure fantaisie est devenu une réalité qui façonne le monde d'aujourd'hui. Effectivement, on vit dans une ère où les frontières entre l'impossible et le possible s'effacent de jour en jour, où l'intelligence artificielle transforme nos vies, que ce soit dans le domaine du divertissement, de la communication ou même du travail. Mais cette avancée si rapide nous pousse à nous questionner. Allons-nous devenir dépendants de l'IA ? Certes, elle peut améliorer notre bien-être, car elle facilite l'accès à l'information, optimise notre temps et offre même des outils d'apprentissage personnalisés. Avec le développement des chatbots, l'interaction est encore plus naturelle et les réponses plus faciles à obtenir. Plus besoin de chercher dans des livres longuement ou de réfléchir beaucoup de temps à une question complexe. L'IA le fait pour nous. En effet, on se demande alors, pourquoi fournir tant d'efforts quand la réponse peut venir juste qu'entre nos mains, en un clic ou en moins de 30 secondes? Attendez, donc vous me dites, moins d'efforts et de temps pour un même résultat? Qui peut refuser? Et c'est là que débute un cercle vicieux, où nous dépendons de plus en plus de ces outils, et parfois même au détriment de nos capacités cognitives. Prenons un exemple qui vous parle à tous, le GPS. La majorité d'entre nous, pour se déplacer d'un point A à un point B, utilisent le GPS pour penser à quelque chose de plus important. Mais en l'utilisant sans cesse, on ne sait même plus s'orienter par soi-même. Résultat, pour ne pas se perdre, on est obligé d'utiliser le GPS, et voilà la dépendance. Néanmoins, il faut tout simplement utiliser l'IA de façon responsable. Plutôt que de la voir comme un substitut à notre intelligence, prenons-la plutôt comme un outil de complément. Il est essentiel de toujours garder un esprit critique et de toujours continuer à exercer notre pensée et de ne pas tomber dans la surconsommation. Effectivement, l'IA ne cessera de se développer. Et comme le dit un des pionniers de l'intelligence artificielle et du deep learning, M. Yann Lequin, ce n'est pas l'intelligence artificielle qui est dangereuse, mais c'est l'utilisation que nous en faisons. Merci à tous.
Merci beaucoup, Zineb. And that GPS example was very personal. I remember when I first joined UM6P, in my first weeks, even months, I would ask my colleagues to send me their location to be able to find them. And I think that's quite relatable. So in his speech, Mr. President mentioned the resources that Africa has, and one of them is phosphorus. So how about we speak about how we can shape the future with such resources? And there is no one better to speak to us about shaping our future with phosphorus than Jacob Jones, who is a Kobe Steele Distinguished Professor of Material Science and Engineering and Director of the Science and Technology for Phosphorus Sustainability Center at North Carolina State University. Please join me in welcoming Professor Jacob Jones. Thank you.
Good morning. Is the robot going to help me, Foad? All right, it's an extreme honor to be here today to represent a center in the U.S. that's focused on the topic of phosphorus sustainability, the STEP Center. Through STEPS and other projects like the nanotechnology project listed, the RTNN, we work in highly interdisciplinary sciences that cross the physical, life, social, and economic sciences. And that's the first reason why engaging in a project like Science Week at UM6P is so exciting. The second reason we're excited to be here is because the importance of Morocco to shaping our global future with phosphorus. Morocco is the ideal location to have such conversations because of your key position in the world and in phosphorus sustainability. In a week dedicated to shaping the future, it's useful to set the stage by recognizing some of the incredible human scientific achievements of the past. As a society, we've accomplished some incredible things, only a few of which I'm able to list here. We've discovered and manipulated matter at atomic and molecular scales, including the scales that define our lives, such as DNA. We've created artificial intelligence. We've explored the universe by scientifically advancing space travel, telescopes, and even landing on Mars. All the while managing to feed the Earth's growing population, which now exceeds 8 billion individuals. But as we move forward, we find ourselves with a new set of challenges. We've pushed the limits of our planet to extreme conditions. In the framework of so-called planetary boundaries, we've exceeded the safe operating space for humanity on Earth in 6 of 9 areas. The graph at the right shows the extent to which the safe operating space, shown in green, is exceeded for these different areas. You can visually see how the zones of increasing risk, shown as yellow, red, and purple, are quite extreme. High-risk zones are identified for things like genetic biodiversity, atmospheric carbon, and the biogeochemical flows of key nutrients like nitrogen and phosphorus, meaning that there's an urgent and important need to better understand these key Earth systems to protect ourselves. These are all, both individually and collectively, grand scientific challenges. And with grand challenges, we must not only decide which problem to tackle, we must decide how to go about conducting the science to offer solutions that make a difference in these highly complex problem spaces. And this talk is as much about phosphorus as it is about our scientific approach to studying phosphorus sustainability. What we must not do is work in silos as scientists. We know that siloed research can result in unintended consequences. Examples of the past include science leading to the use of lead in gasoline and the proliferation of asbestos and plastics. In contrast, we have to consider how our work in one area is interlinked with other key Earth systems, identified in a recent United Nations report as climate, water, biodiversity, food, and health. Across these major categories of life on Earth, cross-cut topics like soil, energy, and phosphorus. This nexus interlinkages approach builds upon other frameworks for facilitating highly interdisciplinary science. Concepts like the convergence of knowledge and technology for the benefit of society, and convergence of nanotech, biotech, information, and cognitive technologies. These are concepts that are recognized in the program of Science Week. There are entire fields of science built around the opportunities at these intersections and the methods of conducting science in these highly interdisciplinary spaces. And these approaches are gaining traction, which is important as we look to shape the future of science. In the US especially, there's a recognition that these scientific approaches are captured simply as convergence, and that pursuing convergence is a paradigm shift in the conduct of scientific research. In contrast to working in isolated fields or areas, Convergence acknowledges that we must integrate a range of knowledge bases, including but not limited to things like microbiology, computer science, and engineering, to yield critical advances across a broad range of sectors, from healthcare to energy, food, climate, and water. Convergence approaches were catalyzed for us in 2018 as our National Science Foundation adopted one of their 10 big ideas as growing convergence research, citing its importance in protecting human health, understanding the food, energy, water nexus, and exploring the universe at all scales. They said we must merge ideas, approaches, and technologies from widely diverse fields. So we accept that we need convergent science to first understand complex problems facing society, to second intervene in those complex systems with real solutions that are adopted and consider the interlinkages with other systems so that we can solve society's grandest challenges. In the STEP Center, we focus on phosphorus, which is critical to all life on Earth, especially in the food system because of its influence on crop yields. Indeed, it is the element that enabled our global society to feed those 8 billion humans. Phosphorus sufficiency is visually apparent in this photograph at the left, where you can directly see its influence on plant growth. Over the last nearly 100 years, the sustained use of phosphorus in fertilizers in agriculturally productive areas of the world, combined with other factors like the Green Revolution, have steadily increased annual crop yields, as shown for corn on the right. As we look to shape the future, we ask ourselves whether or not such growth is sustainable. Considering biogeochemical flows of phosphorus as a system, this mass flow diagram shows us the approximate relative mass of phosphorus flowing through the global food system, where the arrows represent the mass flows, much like differently sized pipes for different volumes of water. On the top left, you can see the primary use of phosphorus in fertilizers. When it enters the global agricultural sector, you can see that a lot goes in and relatively little comes out. This imbalance is due to the inefficiency in most cropping systems, which leaves a large amount of phosphorus in soils. We can also see that globally, there's a significant loss of phosphorus from agricultural waste and human waste to surface waters, as shown in the lower right, causing downstream problems with water quality. And finally, in a diagram like this, we can see our role as humans in this system, relatively minor, but it's our behaviors that create and control the entire system. So what will the future bring? Over the next 75 years, as shown in the graph at the right, the United Nations projects that the greatest population growth will be in sub-Saharan Africa, which will eventually exceed the population in all other areas of the world. This population explosion will need to be fed, and phosphorus will be required to do it. Therefore, we will see substantially increased demands for phosphorus fertilization. We could go one level more granular and look at projected phosphorus needs in specific countries. And we can see examples like Nigeria, which is projected to need an over 900% increase in phosphorus between now and 2050. This growth mirrors the growth we've already seen in other parts of the world. So it could be useful to look to history to see examples of how well it can be managed, as well as to recognize some mistakes of the past. In the US, for example, where we saw agricultural productivity steadily rise for nearly over a century, that sustained productivity has resulted in negative consequences downstream in the Gulf region, where one of the world's largest hypoxic dead zones continues to grow, now at over 17,000 square kilometers, with negative impacts to the economy, the environment, and recreation. As we think about shaping the future, we also need to consider phosphorus used to feed and manage livestock. Of all of the mammalian biomass on Earth, humans only account for 34%. Livestock is a much larger consideration for food and phosphorus management. So we consider opportunities to recover phosphorus from managed livestock waste. And again, thinking to population growth in certain parts of the world. In sub-Saharan Africa, for example, it's anticipated that by 2050, beef and poultry consumption will increase tenfold relative to today. providing a real opportunity for phosphorus management and phosphorus recovery. But elsewhere in the world, there are other trends in the future of food, such as the development of artificial meats, including cultured meats. These often involve entirely new ways of producing food, far from traditional agriculture. Data at the left shows that the global cultured meat market is growing rapidly, indicating a trend not to be missed. We think it's important to understand both what is driving these demands from a consumer perspective and how phosphorus flows through the artificial meat industrial sector. We've already connected such shifts, as expected, as having a positive impact on greenhouse gas emissions due to the reduced methane emitted from harmful algal blooms throughout the world. And we're partnering with other centers who work on this topic to make sure that phosphorus is considered in these various food trends. As one example, some on our team were awarded a large center from the Bezos Foundation to study alternative proteins, including cell-cultured meats and plant-based proteins. In the beginning, I mentioned that we are especially excited to be having conversations on shaping our future with phosphorus here at UM6P because of Morocco's leadership position in the global phosphate and fertilizer markets. Conversations that we've already initiated and continue to develop as shown at the right. Data like that from the U.S. Geological Survey, graphed at the left, evidences Morocco's phosphate rock reserves as largest in the world at around 70%. This is a position of great importance and influence. And although it's reported that China mines more phosphate rock annually, that's the gold bar in the middle, China's export restrictions severely limit the amount that reaches other parts of the world. Therefore, Morocco is also the key leading phosphate rock producer that contributes to feeding the world. Recognizing some of these sustainable growth challenges, especially in the U.S., our National Science Foundation funded the world's largest academic research center that's dedicated to studying phosphorus in 2021, known as STEPS. STEPS studies the convergent science underpinning phosphorus sustainability and the technologies and best practices that can be used to manage phosphorus. It's known as a convergence research center because of the integration of highly disparate disciplines across the physical life, social, and economic sciences, as well as the stakeholders who have a vested interest in phosphorus management, either directly or indirectly. To illustrate the extent of interdisciplinary science in the center, STEPS includes research that we say crosses 17 orders of magnitude in length scale, from what we call the material scale at the left, to the scales at which humans interact with technologies, to regional and global scales. And as one example, we have several specific research projects in STEPS that collaborates and integrates material science with environmental engineering and sociology. It's often challenging to work in such highly interdisciplinary groups, but we see success because we adopt the best practices in fields like team science. Some of those best practices involve finding tangible objects called boundary objects that the team uses to integrate across disciplines and with stakeholders. We created a concept called the Triple Bottom Line Scenario Site, or simply TBL site, to make these complex problems more specific and tangible for studies. TBL sites are specific locations with well-defined geographical footprints that allow us to define inputs and outputs of phosphorus, understand system constraints, and learn stakeholder narratives. These sites also contain real field test sites for testing new materials, innovations, and interventions, and they're locations of research and student immersion. The first 3 TBL sites we created are focused on the rural farmland in the US, urban ecosystems, and aquatic ecosystems. And we recently published a long paper, shown there at the bottom, describing how we use these TBL sites to advance convergence research for phosphorus sustainability. With this convergent science approach, we look holistically at the flows of phosphorus through societal and industrial sectors represented artistically at the right. And we reimagine how to use technologies, best management practices, industries, and business to advance sustainability in this highly complex system. For example, the use of large, complex data sets, remote sensing, and AI to identify hotspots in agricultural systems for large pools of untapped phosphorus, and science and technologies to convert between various forms of phosphorus, especially to make it bioavailable to plants. As one scientific research highlight, we've advanced large-scale spatio-temporal understanding of phosphorus flows across continental dimensions using Bayesian hierarchical modeling. Each year in the US, we input up to 3.6 teragrams of elemental phosphorus into our ecosystems. We can see the locations of those inputs in the map at the top. In addition, we can track hydrologic losses and other factors that contribute to water quality issues, including the agriculturally productive middle of the country, which tells us the sources of the phosphorus driving that dead zone in the Gulf region mentioned before. Importantly, as listed in the last bullet, our understanding of how climate, agriculture, and soil chemistry drive phosphorus concentrations reinforces the need for targeted nutrient management that's specific to ecologically heterogeneous areas of the world. The social science research for us is just as important as the other science and engineering work. In STEPS, we study how decision makers in phosphorus sustainability make those decisions. For example, how wastewater treatment operators decide how to adopt new phosphorus recovery technologies using microbes, and how building designers and managers consider new urine diversion technologies to recover phosphorus on site in urban settings, and how phosphorus source tracking using isotopes of phosphorus and oxygen can inform government and public policy. These types of activities add value to solving this complex problem and involve comparably rigorous research methods to study diverse technology sets and very different types of geographies. As you've seen, involvement of stakeholders is key to how we conduct science. We define stakeholders as those who have a vested interest, directly or indirectly, in the process or the outcomes. And in STEPS, we even embed stakeholders in the design of the research projects themselves. Our most recent demonstration of this was through having scientists and wastewater facility personnel co-create a research project to better understand and control a biological process to remove phosphorus from wastewater. Not only is the work directly informed by and addressing these on-site issues, the wastewater facilities communicated with each other in a way that was previously not realized, and that communication continues today. For us, the involvement of stakeholders is also facilitated by our university's so-called extension arm, which places agents of the university in every small county in the state. We work with these extension agents who communicate directly with farmers and local authorities about our scientific results at the center that can improve agricultural practices and increase crop efficiency. Such extension programs could be catalyzed in various other ways, including through, for example, commercialized services helping farmers with things like soil fertility and nutrient cycling. We pulled together the concepts of TBL site, stakeholder engagement, and extension in the form of a science retreat this past year. Held in the Everglades in South Florida, a massive area of both wetlands and agriculture, we talked with farmers and government officials about their successes and challenges with phosphorus management. And collaboratively, both informed research projects and co-created a new project idea that was subsequently funded by our National Science Foundation to answer key questions about how to further balance very small amounts of phosphorus in very large volumes of water. These partnerships or relationships with individuals who are directly or indirectly affected by our work and outcomes is incredibly important. STEPS has also taken a leadership role nationally in driving consensus around strategies for phosphorus sustainability. We produced a roadmap in 2022 that's specific to our situation and opportunities in our country, but complements several other roadmaps available elsewhere. The roadmap identifies the top 9 impact opportunity spaces for phosphorus sustainability. These opportunities promote ideas like, starting at the bottom right, optimizing use, reclaiming waste, recovering valued products, reducing wastes, and enhancing monitoring. It also makes suggestions on how to grow markets and accelerate solutions, as well as the need to increase awareness of phosphorus sustainability beyond agriculture and into society at large. And while a lot of our work is conducted on our side of the world, we also recognize that we live in a highly interconnected world, nearly everywhere which is dependent on phosphorus. In this particular project, the team studied how unanticipated events and cascading effects can impact phosphorus markets globally, so-called exogenous shocks. Shocks like war, the pandemic, as we saw 5 years ago, and natural disasters, which we see all too often. The team further identified pathways to enhancing system resiliency, including the science needs, like improving phosphorus use efficiency in plants, and once richer with phosphorus, utilizing legacy phosphorus in soils. And as STEP's partners globally, there are many other important opportunities and considerations. We should ask the question, how do we converge globally to shape our future with phosphorus? This is indeed an opportunity that's not incumbent on any individual or specific project or organization or any specific area of the world, but it's a burden we should all consider helping to carry, given that we all live in such interconnected and interdependent systems. We should cooperate and collaborate across continental, territorial, and governmental boundaries to shape our future with phosphorus, both locally in our own settings as well as globally. Given the state of the earth, such international cooperation is both urgent and important, and can be accelerated through collaborating across the many organizations that represent different areas of the world, some of which are shown here at the right. And to bring this back to science, here at Science Week, principles of so-called collaborative governance, it's an area of the social sciences, can even be used to help shape how that collaboration and cooperation could be conducted for best impact. In the spirit of global collaboration and elevating the awareness of phosphorus to the public, and in celebration of our favorite element on the periodic table, the 15th element, we continue to elevate the 15th week of every year as Phosphorus Week. With our partners and other stakeholders, we use this week of the year to raise awareness of the importance of phosphorus and the opportunities and challenges of management in agriculturally productive areas of the world. So follow us on social media, for example on LinkedIn, to help us amplify phosphorus starting April 7th. And for those working in this space, consider joining us at the next Sustainable Phosphorus Summit to be held in Ghana later this year. The most recent SPS, the 7th, was hosted by the STEP Center in the US back in 2022. As SPS is the world's largest convening on the topic for students, scientists, and practitioners, it's an ideal opportunity for us to continue to converge globally, while in a location that is so crucial to consider as we shape the future. Now, while students have been mentioned several times on earlier slides, we wanted to take an opportunity to recognize, in line with all of your thinking apparently, that the future is all about those who will be here, and that's the next generation. We believe that they can both shape the future and change the world, and they are leading with that in mind. In STEPS, for example, they're driving our seminar content, running journal clubs and writing groups, and even taking part in evaluation of the center itself. Our students have even taken it upon themselves to create and run a podcast available on most podcast platforms called Phos for Us, which I think is pretty creative. They reach out and interview subject matter experts and produce content that's understandable to the public, directly helping with the increasing awareness opportunity identified by our roadmap. And now in their second season, there's a lot of listening content available. And as the data shows on the right, most of our listeners are from the US, the UK, India, Australia, and Germany. So there's an opportunity to grow participation from Morocco, both as listeners as well as content creators. Finally, on this last slide, we want to acknowledge some contrasting perspectives of the past. First, the voice of William Voigt, who played a pivotal role in shaping the modern environmental movement. His advice would be careful. And second, the voice of Norman Borlaug, who's often called the father of the Green Revolution. His advice would be, innovation will solve all of our problems. Borlaug is the quintessential techno-optimist. By applying convergence in our work, we understand both of these competing perspectives and encourage our students and postdoctoral researchers to become so-called systems innovators, to find solutions to complex societal problems like phosphorus sustainability and similarly important ones like zero hunger, clean water, sanitation. The world's population will continue to grow, there's no doubt, and we will need to feed them. Think with us about how to innovate in this space. Thank you again for the invitation to be here and share our work and perspectives in this important global conversation. More on this topic is available in Science Week tomorrow in session C2 under the Global Critical Zone Science Chair. Thank you.
Thank you so much, Professor Jacob Jones. All research ends up saying and proving how Africa has the resources to respond to its needs and those of the world. Keywords for me were convergence, sustainability, collaboration, cooperation, and youth. And speaking of the content that you have mentioned, Professor Jacobs, it brings our thoughts to what about misinformation? What information out there is to be consumed and what is to be double-checked? And Marwa Ulfa, a student from the Higher Institute of Biological and Paramedical Sciences, is going to answer this question about how shaping the future of healthcare is challenging in the age of misinformation. Please welcome Marwa.
Ladies and gentlemen, science is all around us. But not all sciences feel equally personal. Take physics, it's happening all around. But unless you're in the field or someone who overthinks how planes stay in the air, you're probably not debating Newton's laws in your free time. But medicine, oh, we all have opinions on that one, whether it's from our doctor, our grandmother, or that one video we saw on social media. We're constantly bombarded with health advice, some of it good, but most of it questionable. Welcome to the misinformation pandemic, where one scroll through the internet can convince you that your entire diet is a death sentence. One post says eggs are a superfood, another says they're basically heart attack grenades. Even water isn't safe anymore. You drink tap water, toxins. You drink bottled water, microplastics. You drink alkaline water, well, a marketing scam. And suddenly you're left standing in your kitchen, staring at your breakfast, wondering if you should eat it or call a lawyer. But why is this happening? Because health is complex. It's personal, and although we fought many infectious diseases through vaccines and we've somewhat managed chronic illnesses, cancer is still a battle that we haven't won, and the last thing we need is more battles, especially ones we created ourselves. Since science is not a solo act, it's a neighborhood. Every field has its own house, and while some collaborate, others expand recklessly into each other's spaces, and what was once a discipline's innovation can become another's crisis. The food and chemical industries, they manage to make the food tastier, cheaper, and longer lasting. But they also mass-produce obesity, diabetes, and heart disease. Agriculture, we opted for bigger, faster-growing crops, but in the process, we introduced pesticides and genetic modifications that alter the very definition of healthy eating. Fashion isn't harmless anymore with toxic chemicals in fabrics, and the air is completely polluted. And even though we've made advancements in psychology and psychiatry, stress, anxiety, and depression continue to rise. And then there's the placebo effect. So you're telling me if I believe I'm sick, then my body may actually play along. So what happens when our subconscious is constantly flooded with misleading, fragmented health advice online? Not everyone can fact-check with specialists every time they see a viral health hack. That's why, as healthcare professionals, as a science community, we must take responsibility. Shouldn't the standards for publishing scientific papers apply to this type of content, especially since it concerns people's health? Because as we shape the future of healthcare, it is important to sustain the fact that science is not about moving forward. It's about making sure no one gets left behind. Thank you.
Thank you so much, Marwa, for this inspirational talk of how we should be very aware of the information that we consume. But this hasn't always been our relationship with science, because scientists have not always been seen same. And this is why Anang Jidam from the Africa Business School will walk us through our relationship with the history of science. Please join me in welcoming Anang.
Good morning, ladies and gentlemen. My name is Anang Didam from Kaduna State, Northwest Nigeria. Last week, after a WhatsApp call with my dear dad, he sent me a message that read, Anang, please remind me, what did you say I should ask Meta to do for me? Did you say ChatGPT? And I smiled and replied, no, Dad, ChatGPT. We're in the middle of an AI revolution, and my dad just heard about ChatGPT for the first time. Well, can I blame him? He's among the first in his family to access formal education, and his courage has actually paved the way for me to access education and to also engage with the science and technology of my time in ways that he never thought possible. As far as he's concerned, WhatsApp is still the pinnacle of technology today. Now, when I think about, the truth is science and technology shapes us differently. Our access, understanding, and use of science vary from person to person, from place to place, and from generation to generation. Across Africa, many like my dad, both young and old, are still disconnected from today's scientific realities. So, when I think about the future, I think about my little nephew, Podrick, the smartest, most curious 5-year-old that I know. What will the future of science be for him? Will his colleagues be AI? How do we ensure that he is connected to the scientific realities of his time and even compete globally? Just like my dad, I also have a responsibility to prepare Podrick for a tomorrow that we can barely predict. The future looks different depending on where you stand. While developed nations race towards human and AI integration, most of Africa is still at breaking dawn, still struggling with basic access to electricity and the internet. Therefore, for me, in Africa today, the future of science is of taking responsibility. I have a responsibility to build on my father's efforts and model bigger possibilities for the Podricks of Africa. And for us as Africans, the future is not just about developing new technologies and chasing global trends. We must ensure that the innovations we create save time, save energy and resources while meeting the critical pressing needs of our continent today. We must build globally while keeping our local context in mind. And even though we're just at dawn, the full day is ours to shape responsibly. So, what is your own history with science? What do you see the future, and how will you shape it now? What is your unique role in closing the technological gaps in Africa? Remember, the future of science is of responsibility, our responsibility. Thank you so much to UM6P for already blazing the trail in science and technology for Africa, and for also giving me a sweet home away from home. Thank you.
Thank you so much, Anang. And just as you said, shall we make sure to learn how to use ChatGPT, or shall we pay more attention to the basics, to what's more important, if we dare to call it so? Will I answer that question? I'm not sure I can, but Mehdi Bakkar, a student from Lemin, is going to speak to us about l'avant-imagination du futur, how the future can be shaped through AI. Please join me in welcoming Mehdi.
Futurs ingénieurs de profession se vont auteurs de profondes réflexions. En 3 minutes, déjà quelques secondes écoulées, je dois relever les défis complexes d'imaginer l'avenir. Moi, qui ai longtemps cru en l'existence d'un déterminisme absolu et que les événements à venir ne nous seront accessibles qu'une fois le démon de la place incarné. Une croyance qui vient de se briser par l'indéterminisme imposé par le monde quantique. Un passage scientifique pour montrer le chaos qui habite mon esprit. Mais après une bonne tasse de café, une feuille et un stylo, je vais vous le partager. Un voyage au cœur de mes pensées. Je ne peux imaginer le futur sans une approche à la fois scientifique et philosophique. La science a nourri notre soif de connaissance en nous montrant que la méthode scientifique peut décortiquer le monde et en dévoiler le secret dont l'usage varie selon nos intentions. Je me demande souvent, que cherchons-nous réellement? Et je m'interroge souvent sur ce nous, ce collectif auquel je suis censé appartenir. Pourtant, j'ai l'impression que la décision se prend sans moi. Cette impression, étrangement, semble partagée par de nombreux membres de ce collectif, faisant émerger une question centrale. Comment puis-je imaginer le futur, moi, jeune talent, sans avoir d'influence sur sa construction? Cela me rappelle la célèbre expérience de la chambre de Marie, où l'imagination devient impossible, mais cette fois-ci, c'est par manque de données et d'influence. Suis-je le seul à faire cette réflexion? La vague des récentes avancées technologiques a figé nos cerveaux, et nous savons pertinemment qu'une fois une chose gelée, les structures les plus solides deviennent cassables. Un moment peut-être qu'à l'instar du démon de Maxwell, nous tentions d'inverser l'ordre naturel des choses et ainsi de lancer un défi contre l'entropie. Mais une chose brisée de cette manière-là est destinée à disparaître une fois pour toutes. La réflexion de nos jours est un fardeau, un poids insupportable, rappelant les misères de Sisyphe. L'humanité a su parfaitement identifier son propre talon d'Achille. Je peux continuer à explorer cette réflexion encore de nombreuses minutes sans fin, mais je choisis de le faire autrement. Je vous invite vendredi matin de 9h à midi, bâtiment Emin, Amphi A, pour découvrir nos réflexions, nos futurs ingénieurs. Ainsi se clôt cette aventure chaotique dans les jungles de mes pensées les plus profondes, précisément le volet futur. Ce pessimisme génère un optimisme, une croyance ferme au potentiel des jeunes talents, qui, sans eux, tout futur brillant imaginé ne restera que de l'encre sur des papiers, en espérant que mon encre se soit ancrée dans les esprits de l'audience. Merci.
Thank you so much, Medjib. What are we looking for exactly? And if the answer was food security in Africa, there would be no better person than Professor Ken Giller, an emeritus professor of plant production systems at Washington University, authored nitrogen fixation in tropical cropping systems, who also leads initiatives like N2 Africa and co-chairs SDNS Thematic Network 7 of the UN. Please, Professor Ken Giller is already here, but a round of applause for him. Thank you.
Thank you. Well, thank you so much to all those young, inspirational talks, because here I am as part of history, and the future is yours, and you are the people who are going to have to take this forward. And I thank also the other speakers this morning on phosphorus. Jacob, I'll be talking about phosphorus. On philosophy, I would say I come from a very empirical, observational background, but where Heidegger and the being in the world, the importance of context, actually determines everything that I do. So I'm talking about really one of the biggest grand challenges, one of the most difficult challenges that we've got to face in future. And I have half an hour to do that. So how will we achieve food security in Africa in the future? All of us want access to nutritious, healthy food. I was in a supermarket in the United States in Seattle, and I took this picture. I was chased away because that's their branding. I wasn't allowed to take a picture of it. But what is food security then? This FAO definition is food security exists when all people at all times have physical and economic access to sufficient, safe, nutritious food that meets their dietary needs and food preferences for a healthy life. Now, I'm going to be talking in this talk then about a book which is just published this month, Pathways to African Food Security. It's online and it's downloadable. And I'll start touching on the old idea of global food systems, the SDGs, already introduced. I'll be talking about global trends in farms and farming, so particularly about food availability, about shrinking farm sizes in Africa, how that becomes very much a multidimensional problem, and I'll finish with some discussion of future pathways and the choices that we need to make. So first of all, the Sustainable Development Goals, and I'm particularly focused here on SDG 2, ending hunger. We promised as a world that by 2030 we would have ended hunger. I was part of the United Nations Food Systems Summit. I helped to write this rural development report for IFAD on transforming food systems for rural prosperity. And I'm also involved in the Sustainable Development Solutions Network. So that was 2021. If we look now at the 2024 state of food security and nutrition in the world, well, how are we tracking? Well, this graph actually shows us that things are not going well. If we look at the bottom graph, that's the prevalence of undernourishment in terms of on the left-hand side, the prevalence, the percentage of people who are undernourished, you can see it's been creeping up since around 2013. That downward trend was interrupted, basically, by the occurrence of many conflicts. And particularly, we see a rise in the past few years of both the prevalence and the absolute number of people who are undernourished. Now, the global percentage of undernourishment is 9%, but in Africa, we're actually talking about 20%. And that large rise in the number of undernourished is almost predominantly African. This is shown very clearly in this map. If we talk about the global hunger index by severity, you can see that Africa really stands out. Whereas in Asia, hunger is actually plateaued or is starting to fall. In Africa, we're still in a bad situation. Now, I want to go then back to what is the challenge and what's the opportunity? We know that crop yields in Africa are low. This is a complicated graph, but if we start at 100 down there, that's at 1961, and we see the rise in cereal yields in the United States and in Europe, in the grey and in the green, and you'll actually see the area being harvested has actually gone down where yields have increased enormously. So land has been set aside from agriculture for nature. If we look at Asia, you see a very steep rise in yields, a very small expansion of area. In Latin America, there's been a massive increase in productivity since 1960, with some increase in area, and we know, of course, the big concerns about the Amazon basin. But if we look at Africa, actually Africa took off in the 1960s quite steeply and then plateaued. And that increase in food production has basically been done simply by an increase in area. So crop yields in Africa remain low, but that's actually an opportunity. It's an opportunity to increase production, and it's an opportunity for smallholder farmers. Now, if we think about farming, farming depends on labor, it depends on land, and it depends on capital. Very simple economics. What we did in this graph was we looked at the trends in our report for IFAD. We looked at the trends in farming across the world. So what we've done here is we put across land area at the bottom, we've got capital at the top. And what we see particularly in the top right-hand corner is this massive expansion of farms. So we see this in North America and in Latin America, bigger and bigger farms where there's a high land area available, there's a high capital of area. If we see in Europe, there's much less land area available, but we see an intensification with very high capital. Think of the glasshouses in the Netherlands, for instance, highly intensive agriculture. But at the same time, in Africa, we see an increasing pressure on land, so low land availability, very low capital investment, and what we see is a process essentially of marginalization. Now, if we take an example from Australia, this is a slide of a zero-till planter which can plant 500 hectares in a day. It can plant the seed at 5 centimeters. It puts the fertilizer in at 8 centimeters depth. Precision planting, zero-till, one person, 1 FTE to 2 FTE, 2 people, actually managing farms of 10,000 hectares. That sort of agriculture is then what we have to compete with in Africa. And if we look at the nutrient background to this, on the right, we've got there the nitrogen use per hectare against the cereal area harvested. So similar to the graph I showed you earlier about yields against the area harvested. And you can see fertilizer took off rapidly in the 1960s in Africa, and then it plateaued with the policies of structural adjustment, where basically fertilizer use hasn't increased in Africa, and that is actually primarily the cause of these very low yields. Now, we know how to close yield gaps. This is a slide I took in Zimbabwe in the mid-1980s. You can see in the middle a nitrogen and phosphorus deficient crop, unable to grow, the maize around it yielding 3 to 4 times the amount, and that was simply the only difference there was good nutrient management. Now, I've spent most of my career focusing on these wonderful plants, the legumes, which can capture nitrogen from the atmosphere and put it into the mouths of people through the beans directly and leave some behind in the soil for the subsequent crops. And we see different examples here I'll come back to of climbing beans on the left, soybean at the top, cowpea down in the bottom, soybean on the right, where we can see an inoculation response, a response to inoculation with rhizobium bacteria. So we know how to grow these legumes, and they're great for food, for cash, and for soil fertility. And I was privileged to run a grant for the Gates Foundation of $52 million over 10 years, 11 countries, where we really tried to put these technologies to work. And we were using a value chain approach because obviously farmers producing more, they need to sell what the extra that they have. But if we look at these two graphs, these are for 2 different villages in Kenya. On the left, Vihiga, which is very high population density, and we have the farms lined up, 100 farms lined up along the bottom axis. What we see there is the blue area is the area which is used for food self-sufficiency of the family. The red area on the left-hand side is the extra land that the family would need to feed themselves with the current yields. And on the right is the green area, is the area which would be available for investment in other crops for the market. And you can see, obviously, in Migori, where there's more land available, there's much more green there, there's much more land available for selling, for the legumes can be grown for the market. But what we've got then are what we call farm land gaps. The farmers don't have enough land to actually feed the family, given the productivity they have. And what this leads to, though, is this very intensive use of that land, which leads then to the decline of soil fertility in the absence of any inputs. So we find then that small farms, coupled with poor soils, which are becoming exhausted, become what we call double poverty traps. Now, the disappointment, really, of Into Africa running into these barriers of realizing that the context was such that farmers had such small areas of land that they couldn't really benefit on, led us to investigate this in more detail. The first slide I showed there actually made in 2012. This is actually for 2015, a paper in PNAS, where we looked at 13,000 farms across sub-Saharan Africa. So 93 sites, 17 countries. And what we found was that 37% of these households were actually food insecure. That's the horizontal line, the food security threshold. But as we go across to the right, when we see these better off farms, what we find is that they have highly diversified sources of income. The reason that they're food secure is because they're growing food crops, some food crops for sale, but cash crops, but they also have livestock and they also have off-farm income. So they have very highly diversified incomes. Now we took this even further and we went then in our report for the Food Systems Summit, we took all of the data we could find, looking at farm sizes across Africa, and we were actually shocked to find that the average farm sizes are around 1.6 hectares across the continent, but the median farm sizes, if you look at the peaks of those graphs, are nearly all coming out around 1 hectare or less. So we're talking about farm families of 6 to 8 people actually trying to feed themselves off tiny pieces of land. So these small declining farm sizes become a critical constraint. We see, in fact, the areas where we have larger farms, not surprising, are in the drier areas. So if you look at Mali or Niger, you see a larger proportion of larger farms, but of course they're very low rainfall, so the agricultural potential there is much less. So what we find is that small land size actually becomes a hard limit. Even if we close yield gaps, and we know we can double or treble yields, then a large proportion of the households remain insecure in terms of their food. Even a larger proportion remain under the poverty line, and very few households are actually able to achieve what we call a living income, an income which would actually allow the family to send their children to school, if we're thinking about farming alone. Now, when we put up this information, and I've run several workshops with FAO over the past couple of years, people often say, well, then we should give up on smallholder farming. But that's absolutely not the point. We don't question the viability of smallholder farms because this is where 90% of Africans' population still lives. It's their primary source of food. It's producing 50 to 60% of their food, but it's just not enough, if you like, for them to grow out of poverty because of the land area. And this leads me to what I call this food security conundrum. National food security in Africa desperately needs an abundant supply of cheap and nutritious food to feed both the burgeoning rural population and also the urban population. Agriculture is the major contributor to the balance of payments for most African economies. But export then attracts much more government attention than support for smallholders. Because the Minister of Agriculture, when you sit in their office, their job is to make sure that there's enough export going out, that the fuel can be imported to keep the economy going. And so there's very little attention, very often from African governments, in actually developing their own smallholder agriculture. And this leads us to having all of these rural households, what I often call then reluctant farmers, who lack sufficient land or economic incentives to invest in agriculture. And I call this a conundrum because it really is a wicked problem. It's a problem that really demands very innovative thinking to try and break through it because it's very, very hard nut to crack. Now, what happens if we don't expand cropland? We need to boost productivity to restrict the expansion of cropland. 2015 current situation, you can see many countries, you've already got 8 to 12 people or more per hectare of farmland, which is more than you can usually support by a hectare. If we go to the bottom right and allow for the increase in population, if we don't actually boost yields, then you'd have to actually use virtually all the land available in Africa for food production. if we allow some crop expansion, then you can keep the numbers per individual of cropland lower. So inevitably, there will be some expansion of cropland. But if we don't increase yields, we're really heading for basically all of the forests in Africa being lost. So we need to boost productivity to restrict the expansion of crossland. That means we need all the nutrient uses available, but organic resources aren't enough, so we desperately do need the phosphorus, the nitrogen, to actually boost productivity. Now here are some examples then. In Rwanda, what can we do on small farms? On the left-hand side, 2 farmers standing among climbing beans with no manure and no phosphorus added. Very poor yields. On the right-hand side, Mrs. Gasolida, and this variety is named after the farmer there, and she's standing among a crop of climbing beans, which goes way above my head, fixing a huge amount of nitrogen from the air with that boost of phosphorus that actually allows the symbiosis to take place and the nitrogen to be fixed. If we look at the crop after beans, you see maize after maize, or on the right, maize after climbing beans. The nitrogen left behind in the soil can then be a real boost, giving at least half a ton or a ton more cereal in terms of the boost from soil fertility. Here in West Africa, on small farms, these short-duration cowpeas actually yield in the middle of the hunger season. They actually allow them for 2 crops within the season, and very nutritious crops, which give then this blend of energy, protein, minerals, and vitamins that legumes can provide. So we can do things on small farms. Here on groundnut in Malawi, doubling up rows with a good fertilizer, you can see you can double yields because current agronomy is simply not good enough. So very simple investments in good agricultural practice can really help to improve food productivity and food self-sufficiency on farm. So there are positive signs. Africa has moved from being a very sparsely populated continent to having a relatively dense population, and this gives a rise of small towns, the proximity to markets. Those yield gaps are a real opportunity. That's a testament to plant breeding, that we've been able to boost yields, potential yields so much. But in order to fill those yield gaps, we need more fertilizer, we need healthy soils, and that's all of our research on integrated soil fertility management shows us how we can do that. We see a rise in farmer-led irrigation, and we see that farmers respond rapidly to market opportunities. One example of that I saw in Malawi just a year and a half ago is a revolution of soybean production in Malawi. We were working there in the 1990s, and soybean was an unknown crop. We were doing the first experiments with farmers to test out the crop. We go back there now, and the crop is everywhere across the landscape. Well, what's going on? Well, we find that the collapse of tobacco as a cash crop, which I suppose everybody would approve of, has led actually to the expansion of soy as a cash crop. Soy has been replacing tobacco as a cash crop. And on the right-hand graph, you can see that over the past 10 years, we've gone from up to 300,000 tons of soybean per year being grown now in Malawi. This is being grown then by smallholder farmers. Here's a smallholder farmer dropping her crop on the scale. She had 3 kilos to sell that day. It's then consolidated in the middle, and it goes off to the processing factory to produce the soybean cake, the animal cake, which is then being used to feed the livestock, particularly poultry and aquaculture in Africa, which is huge demand for feed. But also we find soy snacks in the supermarket, and of course Malawian soybean oil as a good replacement for imports. On the left here is Frederick Kowaliwali, who's actually producing then the inoculants that he's selling, somebody that we helped to support 10 years ago. We'd never even imagined now that he'd have this amazing market for soybean. So we see these positive signs. We see triggers of change. But if we go back then to that 1960, to the beginning, and we've already heard these statistics mentioned this morning. So we started with 316 ppm CO2 in 1960. We're now up to 427, I heard. I had 425 here at the end of last year, but it's growing rapidly. And if we look at the world's population, we've gone from 3 million to 8 million in the world. But look at Africa's population. We've gone from 0.3 billion up to 1.5 billion. It's been 5 times the population. And that's leading then to this complete change in dynamics of African food systems. Put on top of that then, the increase in CO2, asking climate sciences, what do you think about the future? Well, people are worried about the future of their children, obviously, because of what's going on. And we see an increasing incidence of extreme weather events to disrupt, actually, food production, something we've got to face up to. We've seen this graph already this morning, shifts in the world population. By 2050, 25% of the world's population will be African. From 1.25 billion now, we'll be moving to 2.5 billion people by 2050. More than 1 billion people extra in Africa up to 2050. Beyond that, we could see almost a doubling again by the end of the century. Alongside this, well, we need to save the forests. The Congo Basin, the area in the green in the center there, it's really important for biodiversity as a carbon store, but particularly for the water cycle in Africa. In our book, Doug Scheel has this chapter where he argues much of the rainfall in East Africa, that's the dark red areas, is actually evapotranspiration from the Congo rainforest. If we don't save the forests, we'll disrupt our water cycles, and the problems of drought will be even larger than they are today. So, how do we reap this, what we call demographic dividend? This statistic that I put here first, 420 out of 428 million workers coming on the job market in 20 years will be African. 98% of the growth in the global labor force. That's a fantastic opportunity, but that dividend can only be realized if the conditions in place to actually provide people with jobs. And it's been said there in the middle, the youth employment crisis is a crisis of missing jobs. And given that work in Africa tends to be concentrated in low productivity self-employment, and that the technological advances in manufacturing mean we're effectively in a post-industrial world where factories don't create lots of jobs anymore. It means then that low-income countries coming late to the game can't really benefit from low-wage labor in the way that Asian economies did. So Africa's actually in a difficult place to actually reap this demographic dividend. So in our book, we come towards this conclusion chapter. Where do we look? And this diagram, which I really don't have time to explain in detail, shows that it's a multifaceted problem. But we have a productive agriculture we need. We need resilient ecosystems. We need to provide nutritious diets, and we need to make the benefits of trade. Alongside that, we've got pressures of climate change, international arenas. We've got the opportunity for inclusive economic growth, and that needs effective governance. And we summarize that in what we call 4 drivers of potential change in the future. Potential drivers of food system transformation. And in many ways, we could think of this in terms of scenarios. So what's the first one? The first one is, well, crisis breeds change. In some ways, that's where we're heading now. Farm sizes will continue to decline. Climate change will compound these problems. We'll have an increased reliance on imports. Food prices will become more volatile. And that'll lead to food insecurity and social unrest. I think my message is obviously going down rather badly. Half the audience is leaving at this point. I guess some buses might be going. In many ways, this idea of crises breeding change isn't without precedent. Think what happened after famines in Africa. We've seen major responses to those famines with very positive change. Think about the change of the common agricultural policy in Europe after World War II. Crises can actually trigger change, but only with great human cost. The second driver that we identify is what we call the institutional ripple effect. So some countries then establish an impressive record of effective governance of food systems. Maybe that includes trade protection for domestic producers, targeted subsidy schemes, but the welfare benefits of these policies become tangible, food prices stabilize. This is really most likely to happen in countries that have had strong agricultural growth, so countries like Côte d'Ivoire, Ethiopia, Senegal, which have done very well in the past years, although those past gains can be very fragile, as we've seen in Ethiopia. But when proven successful, these policies could become trend-setting. They could spread. They could result in, at the end though, in large inequalities among African countries, probably with winners and losers. The third driver that we identify is regional or Pan-African initiatives, and we see these taking root already with the East African trading community. But important steps have been taken, such as this African Continental Free Trade Area, recognizing that welfare gains can be had from increasing inter-African trade and competition. This would also give Africa a much stronger chance in global arenas. It also sends strong signals to entrepreneurs wanting to invest in agriculture. If countries then do commit the 10% they say to their agricultural budgets, this could actually lead to the improvements in productivity in Africa that we need. Ecosystems can be better preserved, but if we're managing them effectively across borders. But obviously, for this to happen, there are some huge coordination challenges which would need to be overcome. And the final approach that we identify is one of global responsibility. And particularly in these rather bleak political times, one could argue that this is really dreaming. But we establish a new world order to arrest global warming, to ensure that planetary boundaries are not breached. We acknowledge that the historical emitters that have caused climate change are largely in the global north. And that maybe as part of a reparations agenda, there's much more commitment then to African development because, of course, global environmental and economic progress is going to depend on Africa. At the same time, African governments become more accountable and invest heavily in creating the conditions needed for a conducive agriculture, leading to increases in crop and livestock productivity. The increased population density, which will be driving new markets, will be met with investment in infrastructure and institutions to reduce transaction costs and create more positive feedbacks. Attitudes to migration under this scenario would also change. Circular migration would actually help with the huge problem of labor shortage in Europe due to an aging population, as well as actually being the catalyst for developing skills and developing job markets within Africa. So the youthful population of Africa becomes the catalyst for change. Now, this final driver of change that we identify is undoubtedly the most ambitious. Sadly, the least plausible, but it would also be by far the most effective way to ensure a food-secure Africa in 2050, and certainly with the least human and environmental costs. This is where we came to in thinking in our book, together with all of our partners. So the main messages I have today are that if we're going to address food security, hunger and poverty, we must focus on food production in Africa. We can't rely on imports as we do today. Agricultural development remains the most effective way to reduce poverty and hunger among the poorest in our populations. And smallholder farms are here to stay, major sources of food, nutrition, income security, and for a lack of better options for people. But we question the assumption that economic development can be driven by Africa on its own, due to land fragmentation, the low productivity, and the limited jobs and social security outside Africa, which is really a plea for a much broader economic development, which actually addresses this issue of employment outside agriculture. And that requires a drastic rethink of policies to support agriculture and address this food security conundrum. Now, you could say I'm a dreamer, but I hope I'm not the only one. So, thanks to all my co-authors. We have to live in hope. There's a lot more in the book that we've pondered over the last 2 years, and I hope you'll read and engage with us in this debate. Thank you very much.
Thank you so much, Professor King-Giller, for this talk. Such the best kind of talks, sharing the hard facts, the ones that we have to swallow, the ones that we have to accept, but ending on a very positive, optimistic note. And in drivers of food transformation, you have spoken and mentioned Pan-African initiatives. Well, it just happens that Hiba Hassani from the School of Hospitality and Business Management is going to speak about Pan-African development and its role in developing the future of Africa. Please help me in welcoming Hiba.
To those who believe in Africa's potential, to those ready to see beyond its past, I greet you. My name is Hiba Hassani, a 20-year-old Moroccan, but above all, an African citizen of the world. If you asked me about shaping the future today, the first thing I would think of is the future of my country in my continent. Because too often, we imagine the future of the world as one shared vision, while the truth is, each continent lives its own present, and that present shapes its own future. So, what future are we shaping for Africa? Let's start first with a simple question. Where does the world's finest chocolate come from? First thoughts could be to say Switzerland, Belgium, or Germany. And that is fair, because they are indeed its production pioneers. And batteries, the ones that power our phones, our laptops, and our electric cars, who dominates their production? Correct would be to think of Japan, the United States, China. Now, what about crude oil, pumped every day from African soil? Who turns it into gasoline, plastics, or jet fuel? America? Asia? Europe? Did anyone think of Africa? No. Yet, what is always forgotten here is that the chocolate and Swiss truffles starts with beans grown in Côte d'Ivoire and Ghana. The cobalt powering your smartphones and Tesla batteries is dug by hand in the Democratic Republic of Congo. The crude oil fueling factories in Rotterdam or Houston flows from Nigerian and Angolan wells. Dear audience, if you think I am against globalization of resources, allow me to say that you haven't understood my vision yet. The future I am imagining today isn't about rejecting globalization. It is about redefining Africa's role in it. We all know that Africa is a rich continent that feeds the world's industries. But too often, We are invisible in the stories of luxury or innovation. Africa is the prologue to every one of these stories. But why not be the author? A question that I spent my whole life wondering. Now, what if African hands turned Ghanaian cacao into Ghanaian truffles? What if African refineries turned Nigerian oil into Nigerian jet fuel? Sold to the world with a Made in Africa stamp. Imagine a world where Africa's resources don't just leave. They stay, they grow, and then they leave, exporting with them a real story. By this, I mean to imagine a future moving from just raw materials export to value-added production, where Ethiopian coffee isn't just exported as beans, but roasted, packaged, and branded in Addis Ababa, where Malian cotton becomes Malian haute couture on Mali catwalks and Paris catwalks. In other words, I imagine a future where Africa isn't only a supplier, but also the factory, the designer, and the storyteller. I am African, and I believe that Africa's future isn't only in what we dig up, but in what we build up. Thank you.
Thank you so much, Hiba. Taking Africa from being a consumer to being a producer. And we have asked Kwehi B. Williams Zuman from Emin School about what would it take to shape the future of Africa. One word was his answer: introspection. Calling William to further elaborate.
Distingués invités, éminents professeurs, chers camarades, bonjour. Je suis Koebi William Zouman, natif de la Côte d'Ivoire, terre d'espérance, pays de l'hospitalité. Là-bas, j'ai grandi, mon moi avec, à débit modéré, allaité de connaissances, infusé de savoir, comme pour tenir compte de mon capacité intellectuelle, par ceux-là dont la patience n'a d'égal que le cardinal de l'infini réel. Là-bas, j'ai fait la connaissance d'un Jean Sapiens, un être fascinant, nostalgie d'une époque, nostalgie d'une enfance innocente, d'une enfance naïve. Puis il eut ce vol, cet envol, mon être avec, vers des cieux nouveaux, là où les dunes à la topologie majestueuse et les douces vagues de l'Atlantique s'étreignent volontiers, féeries paysagères, plages resplendissantes, où le souk bondé grouille de vie, explosion de couleurs, de saveurs, de parfums, là où tradition et modernité coexistent en harmonie, héritage millénaire, richesse providentielle. Ici, j'ai rencontré les autres, pas si différents. J'ai vu une humanité, la nôtre, payer la lourde tribut de nos dérives machiavéliques, sombrer dans les abysses d'une ignominie, la nôtre, quand nous avons décidé de faire tribu, faire nation, historique opposition du nous et du vous. Du nord au sud, en passant par chez moi, chez toi, au-dessous de la corne de l'Afrique, j'ai vu une jeunesse africaine aux apparences variées, diversifiées, mais fondamentalement la même. Les aspirations, les craintes, les forces, mues par une ardente volonté d'apporter une pierre à l'édifice africain, hantées par les incertitudes infinies du lendemain, armées de courage et de résilience, assoiffées de connaissances, mes contemporains. Alors que chez vous, développement rime avec enrichissement, chez nous, il est question de répondre aux impératifs civilisationnels les plus élémentaires. Le jeu est trop décisif, la chandelle est trop grande, les enjeux trop importants. Alors que chez vous, la énième révolution technologique rime avec outils de domination stratégique, chez nous, il est question de saisir le train en marche, de concevoir des solutions adaptées à nos réalités, des systèmes intelligents dont le seul bien informationnel serait de croire aux rêves africains. Science sans conscience n'est que vile et laide. Que dis-je? Je parais, moi, au milieu de ce tumulte, cette frénésie destructrice, conscient de ce qui nous attend. Des grands glaciers terrestres aux archipels luxuriants de Maldives, en passant par Pacific Palisades, notre écosystème périt. Là-bas, il est probable que se jouent certains épisodes déplorables d'un futur commun, le nôtre. Le fardeau est lourd. Et maintenant, mon encre tarit, vidé de toute clarté, de toute utopie. Le tourment amer. Je parais, moi, aîné de ma fratrie, Au milieu de ce tumulte fort et résilient, ce regard, le leur, est une impération, un impératif, une injonction. Audaces fortuna juvat, dit-on, la fortune sourit aux audacieux, surtout s'ils sont armés de science et de connaissances. Je vous remercie.
Merci beaucoup, William. And so the last question is, if we got the resources, if we got the brains, if we got all that it takes, why don't we just achieve all that we have just discussed? Why don't we just get whatever that we want? And this is what our last speaker, Dua Dahbi, a student from the Faculty of Medical Science, is going to tell us. The price of humans' progress. Please, ladies and gents, welcome Dua on stage.
As a kid, when our professors used to ask us the inevitable question of what we wanted to be when we grow up, I had no idea. Maybe a doctor, an engineer, or even a painter. Why not? But what I was sure of is that I wanted to leave my mark on this world by pushing science beyond its boundaries for a better future. Because the future for me is not a blank page, but a scroll where the promises of progress are written. Science advanced without turning back, shaping a world where yesterday's dreams becomes today's realities. But if everything possible is destined to exist, who watches to ensure humanity doesn't lose itself in the shadows of its own creation? Take, for example, in the movie Her, the main character developed a familiarity with the unknown. He got attached to a relationship purely digital with his personalized program Samantha, which leads us to think of what it means to love, connect, and exist in a world where artificial intelligence is not just a tool, but a companion. AI started actually as learning algorithm that interacts with data. It gives us incredibly complicated neural networks that are good at doing things. But do we truly understand how it works, and more importantly, where it's taken us? The duality of Einstein and Oppenheimer, for example, represent two contrasting yet deeply interconnected approaches to science, the fine line between scientific progress and moral responsibility. Einstein saw knowledge for the sake of understanding, while Oppenheimer demonstrated how scientific discoveries, when applied, can reshape history, making it better or worse. He does not regret having participated in the creation of the atomic bomb by justifying that scientific progress is inevitable and that someone would have created it sooner or later, because the scientist has the duty to extend his understanding and control of nature. And that's what reminds me of Denis Gabor's law, which stated that everything that is technically feasible will be done. But what I'm sure of is science is not just about equation and experiments. It's about the courage to move forward, to search for answers even when we don't fully understand the question. Every great leap, medicine, space, electricity, came from minds willing to take that risk. They didn't have all the answers, but they had the conviction to ask, what if? We don't have a manual for the future. We can't predict every consequence of the technology we create, but we're sure that the progress demands risk. So to what extent can we take risk in order to improve humanity and not destroy it? Thank you so much.
Thank you so much, Dua. We wish it was that simple to answer the question of the price to progress, but it's not. Fascinating, isn't it? How just two words, shaping the future, can take on so many meanings, explored through different and diverse perspectives across different industries, disciplines, generations, and backgrounds. From science to philosophy, from academia to business, our speakers have shown us that the future is shaped not by just one voice or one way, but many. I hope that each one of you found a perspective that resonated with them, or at least one that challenged them and made them see things differently. And just remember that this was just the opening, just the beginning. The week is still full of so many other workshops, panels, discussions, where you can debate, express your opinions, ask questions, and dive deeper. And before we break, I would like to call again on stage Mr. Science Week, Professor Fouad Laroui, for final remarks. Please and your applause.
Thank you, Kautar. It's just 1 minute, just to a very quick announcement. D'ailleurs, je vais le faire en français pour changer. Le professeur Jacob Jones, c'était pas du tout prévu à parler de convergence. Il a parlé longtemps de convergence. Donc ça me permet, c'est une très bonne occasion, ça me permet d'annoncer déjà le thème de Science Week 2026, qui sera le thème des convergences. Je voudrais, pour tous ceux qui le pourraient, vous inviter à venir ce vendredi, parce que Raphaël Liogier et moi-même, on va présenter le thème des convergences, ce qui permettra d'ailleurs d'avoir une sorte de continuité. Une semaine de la science se finit, l'autre commence déjà. Donc ce vendredi, avec Raphaël Liogier, on va parler du thème de Science Week 2026, qui est convergence. Et deuxième chose que je voulais dire, le livre blanc de la dernière Science Week est paru, donc j'invite Raphaël Liogier à monter pour le présenter en exactement 59 secondes.
Merci.
Je compte pas.
Yes, it's actually, thank you, Fouad. It's actually part of this, of the idea of convergence, and it was shaping the future this year, and last year it was transitions. And in fact, Fouad Laoui and I had the idea that Science Week will not be only an event, but like what science is, some kind of a cumulative knowledge, like the idea that this year transition was something that wasn't just an event, and so that's the reason why we produced a book. It's not a book, and it's available there outside, the white papers of transitions. It's not a book that is about, I will say, the specific conference, because we have built something else. It was rewriting. So it's a book in its own right. And we think that every year we will complete it. So if you want to take advantage of that, of this book, of this, I would say, synthesis, it's outside. That's what I want to say. Oh, yes. Yes, one thing. It was made under the shield of the chair of transitions, which is in the Institute for Advanced Studies of the UM6P. That's important to say.
Merci beaucoup, Raphaël. So before we exit the room, I'd like just to remind you of the exciting afternoon sessions and encourage you to visit the exhibition stands outside, where you can explore all the scientific innovations there and engage with experts that were in the room that are going to be outside. And with that, I guess it's time to wrap up the opening ceremony of Science Week. Please make this a week to remember, make the best out of it, make sure you engage, you ask questions, and you start drafting for the next edition of the Science Week. Thank you again for joining us. Have a lovely afternoon.